Welcome back to the Ductile series of instructional videos. In this video we're going to cover the basic nomenclature and profile types of steel. Now it's important to have fluency with the different types of steel. There are quite a number of standard profiles that we then use and configure to make systems and components from. Now here's an overview of the family, which comprises of both heavy structural steel, which is often referred to as hot formed or hot rolled steel, as well as thinner wall profile steel, such as purlins and girts and so on, which are often referred to as cold formed or cold rolled steel. Now the first very common steel element is the universal beam. Now you need to refer to manufacturers' data sheets to get the sizes of the beams, and it's important to pay attention because under each standard category of universal beam there's a subset of specific dimensions for that. Now the dimensional stability of steel is very good, so you need to be very precise with your detailing to ensure that the way that the steel comes together is very accurate and with very close tolerances and a high degree of accuracy. Universal column, again a very standard steel profile that's used mainly for sort of heavy steel construction. Equal angles, there's generally two different types. Ones which are derived from a lighter, lower grade steel, and then there's the equal angles that are used for more structural applications. Now equal angles are brilliant for making composite elements, beams, trusses and so on, and columns. So they're a very popular architectural choice for structural systems. And the same with the unequal angle. The parallel flange channel is again another hot rolled section, heavy duty structural element. Again, this is something that helps expand the repertoire of design and is very good for making composites and cutting these beams up to make special profile beams is also very useful. Now for medium and I guess domestic scale structures and constructions, the hollow sections are perhaps the most widely used. Now the steel hollow section is typically up to sort of 4 or 5 mil wall thickness, and most of the time it is formed under a cold process. And the rectangular hollow section, where again it's got a bias to it, so can be tuned to specific orientations. So rectangular hollow sections are very popular for portals and for beams, whereas square hollow sections obviously are much easier to use for columns where the loads are more concentric. Circular hollow sections are good again for columns and so on. The way they marry into the more rectilinear elements makes them more of a design challenge. The circular hollow section is used a lot for bracing elements because of the way that they are not that the forces are more concentric to the element. And they also work well for bent or more organic structures because they're again concentric around. You can make some quite complex forms very easily without having to worry about the orientation of the edges. Now the Z-purlin is a classic thin metal cold form section. The base metal thickness is no more than 2 millimeters typically, and it's pushed through in long extrusions. The Z-purlin is used a lot for industrial manufacturing and for secondary systems like roofing and sometimes even sun shading. The C-purlin, again, is a lightweight steel system. It's often used as a replacement for timber studs and is perhaps used more ubiquitously for shop fit-outs and so on, where one needs to be mindful of the lightness and to make more fireproof constructions. It's also very good for running cabling and so on through it, and it can be erected very quickly, and it's very dimensionally stable. So the C-purlin is more ubiquitous in the fit-out and secondary systems market. Now, the steel lintels are typically sort of pre-engineered, both in terms of the size and their capacity. Most steel manufacturers will sell a range of pre-engineered lintels to length. These are used for masonry construction, and the size of them is scaled so that they hide within the cavity quite nicely. Here we can see two different sizes, one which is 100 millimeters by 100 millimeters, and the other for longer lintels, 150 by 100 millimeters. Now, the other, I guess, major use of steel is in composite construction for reinforcing in concrete. Now, the reinforcement bars are often called deform bars. They have these little raised elements or nodules that are along the length of them, and these help form a key with the wet concrete when it's poured, so you get a much more monolithic composite structure. Now, the smoother steel rod is used often in combination with deform bars to make, I guess, cages and other elements that help pull all of the reinforcing together and make it a three-dimensional system. Cables are used, I guess, more commonly as either secondary systems for tension structures and so on, or for really heavy construction for large-scale suspension structures like bridges and so on. Ostensibly, it's comprised of a loom of drawn wire that is bundled and twisted together to form a very strong element in tension. The other steel that is very commonly used for architectural applications, like for balustrades, for decorative steel, for handrails, for gates, and for fences and other ironwork, is what's called merchant steel. Now, merchant steel is typically a lower grade steel, and it comes in dimensions that are more suited to that smaller scale of architectural steelwork. They usually come in angles, flats, solid squares, and rounds, and these combine together to form in a myriad of different configurations for most decorative architectural work. Well, that completes the introduction to the family of steel elements. Again, the most important thing is to refer to the manufacturer's data and the availability of these different elements to get the precise size, because there's no point in guessing. You need to be absolutely millimeter accurate with the dimensions of these elements. So thanks again for listening, and stick around for the next instructionals.